Hello friends, welcome to the session. In this session, we will be discussing about insertion and deletion operation in linear arrays. This session is concerned, we will see how to write algorithm for insertion operation and how to write algorithm for the deletion operation. Friends, as you know that I have been recording these sessions for the PSS Central Institute of Vocational Education, and we have been recording it for the course Junior Software Developer. But the students from the other courses also can make an access to these sessions so that they can learn computer science or they can learn the data structures. So let us start the session with the question how we can perform the insertion operation in the linear arrays. Insertion operation, as its name indicates, adding an element to the existing set of elements of the array. Suppose you have been provided with certain array and there are certain elements already present in the array. And now what you want to do is that you want to add a new element, an additional element into the existing elements. And whenever you want to do this operation, then this operation is being called as an insertion operation. Now, element can be easily added at the end. Adding the element at the end is very easy because there is an empty space in the memory, and we know that in memory we have been allocated a certain amount of space for the array. So if there is an empty space, then at the end you can easily add the element. But whenever you have been asked to add the element in between, then you will find that you need to create a space, because unless and until you create a space, the new element cannot be added. And when you want to create the space, then you have to move the other elements of the array, and when you move the other elements of the array, you will find that their index number will also change. So whenever you want to add an element between the two elements, then we need to create the space by shifting the rest of the elements. So as shown in this diagram, suppose we have been given original array where it will consist of 5, 1, 4, 2 and 6. So these are the elements of the array, original array. And now I want to add this element 3, and if I want to add this element 3 at the end, then it is very easy for me because there is empty space in the memory, and therefore I can easily add this 3. And after addition, now there will be change in the number of elements. You will find that now the number of elements will be 7 in the array. So let us understand how to write algorithm for the insertion operation in the linear arrays. Now suppose we have been given a linear array, and suppose LA is the name of the linear array. And suppose we have been given an element, and this element we call it as an atom. And suppose we want to insert this atom in the kth position in the linear array. So what we will do in the first step is that we will set j is equal to n, where n will stand for the number of elements of the array. And we will repeat the steps 3 and 4 while j is greater than or equal to k. So we have taken some variable j. So the initial value of the j will be n, and we will repeat the step as long as the k is less than j. As soon as the j becomes greater than or equal to k, then we will repeat the step, and when it not, then we will exit the algorithm. Now in the step number 3, what we will do, we will move the jth element downward so that we can create a space. Now to create a space, what we will do, we will set the index Laj plus 1 is equal to Laj. So the Laj value will be assigned to the next element, and we will decrement the value of j by 1 so that j becomes equal to j minus 1. And you will find that this process will be repeating while j is greater than or equal to k. If it is not, then we will exit the algorithm. And then finally, when the space is being created, then we will insert the element. So for the insertion of the element, we will use the step number 5. And in the step number 5, what we will do is that we will write LAK is equal to atom. So atom is the value that we want to insert, and we are inserting it at the kth position, and therefore we will write this step LAK is equal to atom. And then we will reset to number of elements of the array n is equal to n plus 1, because we have already added one element. So the number of elements of the array are increased by 1, and therefore we will increase the number of elements of the array by 1. That is, we will set n is equal to n plus 1, and the final step will be the exit. So these are the 7 steps that we need to perform in order to add a new element into the array at the kth position. Let us understand it by taking some examples. Suppose we have been given an array where there are suppose 4 elements. Now this first element is suppose 15, the second element is suppose 5, the third element is suppose 25, and the fourth element is suppose 40. So this is my original array, and this is the original array which is consisting of only 4 elements. Now what I want to do, I want to add a new element in the array, and my position will be the after second. So my k will be the 2. So I want to add a new element, and the value of the new element, that is the atom, will be suppose 35. So the value of the element is 35. Now I want to add this element 35 into my existing array, and I want to add it at the second position where k is equal to 2. Now what I will do, according to this algorithm, you will find that we will create a space here. My first element 15 will remain there, 5 will remain there, and then I will create a space here, and the rest of the 2 elements I will move downwards. So 15, 5 will remain there, then 25 and 40 I will move downwards according to this step number 3. And then what I will do, I will create a space here, and now I can add the element 35 into the array. So now you will find that the number of elements in the array are becoming 5. So my original number of elements were 4, but the new element is being added into the array, so that the number of elements in the array are becoming now 5. So this algorithm works perfectly whenever we want to add any new element in the array, and this is the algorithm which we call as the algorithm for insertion. Similarly, we can discuss another operation on the array, and this operation is being called as a deletion operation. So deletion means what? Deletion means you want to remove element from the array. Suppose you have been provided an array, and suppose there are some existing elements in the array, and now what you want to do is that you want to delete some of the element of the array. Now when you want to delete at the end, then it is very easy again, like insertion, because there is a memory space available at the end. You can go to the end upper bound location, and then you can easily delete the array. But if you want to delete in between, then you will find that the space will be created, and when the space is created, then the downward elements of the array need to be moved upwards, that their index will go on changing. So as shown in this figure, suppose we have been provided with array which is a character array and consisting of characters A, B, C, D and E. So there are 5 elements in the array, and now suppose I want to remove this last element E. So if I remove the last element E from the array, then after deletion there will be only 4 elements in the array, and that will be A, B, C and D with the index 0, 1, 2, 3. So you will find that since one element is removed, so now the number of elements in the array are decreased by 1, isn't it? So earlier there were 5 elements, but now we can have only 4 elements. So let us understand how we can write the algorithm to perform the deletion operation in the array. Now this is the algorithm. Suppose we have been provided with linear array, and we will use the variable LA for the linear array. N is the number of elements in the array. K is the position at which we want to delete the element, and the atom that you want to delete is being indicated by the atom. So there are n elements in the array. K is the positive integer, and k should always be less than or equal to n. Now initially what we will do, we will set the atom is equal to LAK, means whatever is the value of the array at the kth position, that will be assigned to the atom, and then we will repeat the step for j is equal to k to n minus 1. So what we will do is that we will move the j first element in the upward side direction, so that Laj is equal to Laj plus 1, and this loop will be repeated until the value of j becomes equal to n minus 1, and then we will reset the number of elements in the array as n is equal to n minus 1, because we have deleted one element from the array, and therefore the number of elements from the array are decreased by 1, and then we will stop or we will exit the algorithm. So in order to understand this algorithm, let us take one simple example. Suppose we have been provided with a linear array, and suppose there are 5 elements. The first one is 25, suppose the second one is 30, the third one is 15, the fourth one is 5, and the last one is 4. So suppose we have been provided with array, but there are 1, 2, 3, 4 and 5 elements. Now suppose I want to delete this 15, so my k will be the third position where I want to delete, and my item value will be the 15. Now what I will do is that whenever I want to delete the particular element, the 25 will remain as it is, the 30 will remain as it is. Now this 5 will be moved upward and this 4 will also be moved upward. So now instead of 15, you will find that that position will be occupied by the 5 and the next position will be occupied by 4. So after deletion operation, you will find that you will be having an array where there will be only 4 elements, 25, 30, 5 and 4. So this particular element having the value 15 at the position 3 is being deleted from the array. So this is a way you can delete any element in the given array. You can delete at the end, you can delete at the beginning, or even in between also. So this algorithm works perfectly whatever may be the position of k, isn't it? The position of k may be at the starting of the array, the position of the k can be at the end of the array, or even the position of the k can be in between also. So accordingly, you will find that the number of elements in the array will be decreased by 1 and the index number of the remaining elements will also change because all of them will move upward. So thank you friends for viewing the session. Hopefully you have understood these two algorithms, one for the insertion and other for the deletion. Always remember that whenever you are making some change in the array, then by making an insertion you are changing the elements of the array. By deletion also you are changing the elements of the array. But whenever you are changing the elements of the array, then always remember that there is a change in the index number of the remaining elements of the array. Also, the total number of elements of the array will also get changed. In insertion it will increase by 1, in deletion it will decrease by 1. Thank you friends for viewing the session.